Imagine a world for a second, a world where the most powerful artificial intelligence, it isn't locked up.
Right.
It's not sitting inside some black box, owned by a single tech giant in Silicon Valley.
Instead of that, picture a global digital brain.
Exactly.
Where you have thousands of computers all competing to be the smartest. And this is the key part. Anyone, including you, can own a piece of the network.
It sounds like pure sci-fi, I know. But it's actually a protocol that's been running since 2021. It's called Bittensor.
Some people call it the Bitcoin of AI. That's the catchy phrase. Others, a little more technically, call it a market for intelligence.
But today, what we're really going to find out is if it's the future of how we think.
Or if it's just another grand experiment.
Let's dive in.
Let's do it.
Welcome back to the Deep Dive. It is Friday, February 6, 2026. And I just think we need to take a second to acknowledge the moment we are living in right now. AI is, it's everywhere.
It's completely saturated. It's in our phones, our cars. I think my refrigerator tried to sell me a poem yesterday.
Right. But there is this massive, massive tension hanging over the entire industry. You feel it in the news every day. You certainly feel it in the markets.
It's the tension of ownership. That really is the fundamental anxiety of our decade, I think.
It's the who controls the switch question. Yeah. And on one side, you have that, top-down world, the walled gardens, OpenAI, Google, these massive tech giants. The intelligence is created behind closed doors, in boardrooms. We don't see the weights. We don't see the data.
It's a black box, a very powerful, very useful black box, but a black box nonetheless.
And on the other side, you have this completely different vision, this bottom-up vision. And that is exactly where Bittensor sits.
That is the battlefield. And the question we are exploring today, based on the sources, is a really big one. Who will own intelligence? Is it going to be a few corporate entities, which is, effectively a digital oligarchy? Or can it actually be a global collective?
And I want to be really clear to you listening. We aren't just engaging in some abstract philosophy today. We have a serious stack of sources to get through.
We do.
We've got the original Bittensor white paper, which is, I have to say, it is dense.
Oh, it's a heavy lift. Yeah.
We also have the technical docs on things called Yuma Consensus and subnets, which, frankly, sound very cyberpunk.
They are very cyberpunk, but they are also the plumbing of this entire new system. It's how the whole thing holds together.
And crucially, we have a really critical empirical analysis from ArcSef. It's a paper that looks at the network's centralization or lack thereof. Plus, we have some fresh insights on the upgrades from late 2025, like the TAO upgrade and something called MEV Shield.
Right. So we're getting the full picture, the dream and the messy reality.
Exactly. We are not just looking at the hype. We're looking at the hard data. We're going to talk about the hacks, the flaws, and the fixes. I want to know if this thing actually works in the wild or if it's just a beautiful pipe dream on a white paper.
That's the mission for today. We need to understand how Bittensor attempts to commoditize intelligence. The stated goal of the project, if you look at their own language, is to move us from the mainframe era of AI.
The mainframe era.
To the internet era of AI.
I love that framing. So let's start there. Let's start with the big comparison, because you hear this constantly. Bittensor is the Bitcoin of AI. Now, that sounds great on bumper sticker. It's a great headline. But what does that actually mean mechanically?
It's the core analogy, and you find it in almost all the foundational documents. And to get it, you have to think about what Bitcoin really did for finance.
Okay.
Before 2009, if you wanted to move value, to move money, you had to trust a bank. You had to trust a centralized ledger. And that bank, it could block you, it could charge you whatever it wanted, or it could just fail.
Sure, you always needed the trusted intermediary.
Always. And Bitcoin came along and introduced a decentralized currency. It gave us a shared value system that was, for the first time, impervious to centralized manipulation. There's no CEO of Bitcoin who can freeze your account.
Because there is no CEO.
There is no CEO. Bittensor is attempting to do the exact same thing, but for a different kind of commodity, not money, but digital commodities, specifically machine intelligence.
So instead of a ledger of financial transactions, it's a ledger of, what, good ideas, computations.
In a way, yeah. It's a ledger of value creation. The white paper makes this really interesting comparison. It says, 2023 is the new 1983.
I saw that quote in the notes and I circled it.
Yeah.
Unpack that for me. Why 1983? What happened then?
Well, 1983 was essentially the moment of transition. It was the shift from the era of massive centralized mainframes. Think of a giant IBM machine in a climate-controlled room that a whole university shared.
Right. The computer was a place you went to.
Exactly. It was the shift from that to the decentralized internet where everyone has a personal computer and they all talk to each other through TCP/IP.
Okay.
Bittensor's argument is that AI today, or at least the AI of the early 2020s, is stuck in that mainframe era. You have these massive monolithic models like GPT-5 or whatever Google's latest model is, sitting in a centralized server farm. We connect to it, we ask it a question, it gives us an answer, but we don't own it, we're just users.
And then this is where that phrase comes in, the unclosable API.
That's the goal. That's the vision. If you look at the current status quo, even today in 2026, companies like Anthropic or OpenAI, they operate these walled gardens. They control the model. They control the access. They can turn it off tomorrow if they want to.
They can censor it. They can change the pricing.
Anything. Bittensor's goal is to create an open source, permissionless library of machine intelligence.
A shared computer.
A shared computer. That is the perfect way to put it. A shared computer that isn't owned by anyone, where anyone can contribute, and crucially, anyone can profit from their contribution.
That profit part feels absolutely key because open source AI has been around for a while. You can go on Hugging Face, which is a fantastic platform, and download thousands of open source models right now. But Bittensor adds an explicit economic layer, right? It's not just about contributing for the good of the community.
That is the core differentiator. It's what makes the whole engine turn. Bittensor acts as a catalyst for the open source movement because it creates a direct financial incentive. In the traditional open source world, you contribute code because of what? Reputation, altruism, maybe you want to get a job at Google, so you build up your GitHub profile.
Right, it's social capital.
It's social capital. In Bittensor, you contribute because the network pays you for the value you create. It directly monetizes the act of making AI smarter.
And this is where it really diverges from Bitcoin mining, right? Because in Bitcoin, the work being done is, well, it's just guessing random numbers, basically.
It's brute forcing a cryptographic puzzle, yeah.
It's SHA 256 hashes. It secures the network, which is incredibly valuable for the network, but the calculation itself doesn't actually do anything useful for the world. It's basically burning immense amounts of energy to build a digital wall.
Precisely. Bitcoin mining is computationally wasteful by design. That's its feature, not a bug. It's security through massive energy expenditure. Bittensor completely changes that equation. It wants the work to be the production of useful intelligence. So instead of burning electricity to guess a number, you're burning electricity to train a language model, or to fold a protein, or to store data for someone.
You're being incentivized to produce something the network itself finds valuable.
Something a human finds valuable.
So if Bitcoin is proof of work, Bittensor is trying to be proof of intelligence.
Or maybe proof of value. The network is constantly asking every participant, did you provide something useful? And if the answer is yes, from the consensus of the network, here is some money, here's some TAO.
Okay, so that's the philosophy. Bitcoin meets brains. I get it conceptually. But I really want to get into the nuts and bolts now, because this isn't just one giant AI model floating in the cloud. It's structured in a very specific and frankly very complicated way. I was looking at the architectural docs and my head started spinning a little bit.
It is complex. There are a lot of moving parts, but we can break it down. If we move away from the abstract philosophy, the fundamental unit of the Bittensor network is the subnet.
Subnets.
Okay.
I've heard this described as an app store. Is that an accurate analogy?
That's a great analogy to start with. Imagine Bittensor isn't the app itself. It's the operating system. It's iOS. It's the platform. And Bittensor creates this marketplace where different subnets can exist and compete. And each one of those subnets is its own self-contained economic market for a very specific type of intelligence.
So one subnet isn't trying to do everything. It's not a jack-of-all-trades model.
No, not at all. In fact, specialization is absolutely key here. You might have one subnet that is dedicated entirely to text generation, like a GPT-4 competitor. Another one might be doing image creation, like Midjourney. And then you could have a completely different one over here that's focused on protein folding for medical research. There are over 100 of these active now.
Wow. And within each of these specialized markets, these subnets, you have specific roles. The sources mention a magazine publisher analogy that I found really helpful. Can you walk us through that one?
Yes, this comes from one of the community explainers on the ecosystem, and it's a great way to picture it. So Think of a specific subnet as a magazine publisher. Their one goal in life is to produce the best magazine possible on a certain topic.
Okay, let's say it's a science fiction magazine.
Perfect. So, to produce the best sci-fi magazine, they hold a writing competition.
Right. Who are the writers in this scenario?
The miners. In the Bittensor ecosystem, the miners are the supply side. They are the ones actually running the AI models, producing the commodity. In our analogy, they are writing the sci-fi stories. They're all competing with each other to produce the best, most mind-bending story because they want to win the prize money.
And the prize money is TAO, the cryptocurrency of the network.
Correct. But here's the massive catch. This is the whole problem. How does the publisher know which story is the best? In Bitcoin, it's easy. You either found the hash or you didn't. It's pure math. 2 + 2 = 4. It's provable.
But in AI, how do you prove a poem is good? How do you prove an image is high quality, or that a Python script that a model wrote actually runs efficiently?
It's subjective. I might love a story that you think is derivative and boring.
Right.
Exactly. And that is the hardest problem Bittensor had to solve. How do you create consensus on quality when quality itself is subjective? And that brings us to the second role, the validators.
The editors.
In our magazine analogy, these are the editors, the judges of the competition.
Yeah, okay.
The validators send out prompts, or in our analogy, story ideas, to all the miners. The miners send back their completed stories, and the validators read them and score them. They are the quality control. And crucially, validators are also the gateway for customers. If you, as a user, want a story, you send your request to a validator, and they route it to the best miners they know.
But wait, hold on. This brings us right back to the subjectivity problem. If I'm a validator, what stops me from just giving my friend, who is a miner, a perfect score every time? Or what stops a miner from just bribing me to vote for them? If I can be corrupted, the whole quality system falls apart.
That is the billion-dollar question. If you can't solve that, the whole network is worthless, and that is where the magic, or at least the very clever game theory, comes in. It's a system called Yuma Consensus.
Yuma Consensus. Okay, the brain of the operation.
Yeah.
I will admit, I tried to read the math on this in the technical paper, and honestly, my eyes glazed over pretty fast. Break it down for me in simple terms.
Let's try. The paper calls it a subjective utility consensus. To explain it, let's ditch the magazine and use another analogy from the technical docs, the University Tenure Committee.
Okay, I'm with you. Lay it on me.
So you have a committee deciding if a young professor should get tenure for life. There are, say, a dozen members on this committee, but they are not all equal, are they? You have the Nobel laureate in physics on the committee, and you have the junior professor who just got tenure last year. The Nobel laureate's opinion, just by virtue of their reputation and experience, carries more weight.
Of course. They have more credibility.
Exactly. In Bittensor, that credibility, that reputation is stake. How much TAO you have locked in the system. Validators who hold and stake more TAO have a heavier vote. Their opinion counts for more.
So the richest validators have the most say. The Nobel laureates.
For better or for worse, yes. But here is the clever mechanism that keeps them honest. The system looks for the consensus among them. It doesn't just trust one Nobel laureate. It looks for the majority opinion of all the stake-weighted validators.
Okay, so it's looking for agreement.
It's looking for agreement, and it punishes disagreement. If you are a validator and you consistently vote in a way that is wildly different from the majority of the other stake-weighted validators, the system penalizes you. It assumes that if the top 80% of the stake thinks a miner's response is good, and you're the lone voice over here screaming that it's bad, then the system concludes that you are the one who is wrong or acting maliciously.
So you are financially incentivized to agree with the smartest, or at least the richest, people in the room.
You are financially incentivized to align with the consensus of value. It's a system that rewards what it defines as honesty, which in this case is alignment with the group's collective definition of quality. It's a very clever, if controversial, way to turn a million subjective opinions into a single objective score that can be recorded on the blockchain.
But I have to ask, doesn't that just create groupthink? If my main incentive is to agree with the whale, the guy with the most stake, then am I really judging the work anymore? Or am I just guessing what the boss thinks? That seems like a dangerous dynamic.
That is an absolutely valid critique, and it's something the developers have wrestled with constantly. It's a known attack vector. We'll talk later about a fix called Yuma Consensus 3, which tries to address that by rewarding people who find good answers before the consensus forms. It tries to reward being a trendsetter. But fundamentally, yes, the system relies on the assumption that the majority of stakeholders want the network to produce high-quality intelligence, because that ultimately makes their own tokens worth more in the long run.
It's a greed is good mechanism, basically.
It is pure game theory. You try to align the selfish desire for personal profit with the network's collective need for high quality.
That is fascinating. It really is like a crowdsourced truth mechanism with all the potential and all the pitfalls that come with that.
It is, and it's what allows this decentralized network to agree on the quality of something as fuzzy as intelligence, without a central authority, without a Sam Altman at the top telling you what is good.
Okay, so we have miners who are like the writers, we have validators, the editors, and then subnet owners who kind of set the rules for their specific competition. I want to make this real for the listener now, because we're sitting here in February 2026, and this network has been running for years. What are these subnets actually building? Is it just 100 different chatbots?
That's where it gets really interesting, because the diversity of what's being built has absolutely exploded, especially in the last year or so. It is not just chatbots anymore, not by a long shot.
Right. I was looking through the list of active subnets in the source material we have, and subnet 51 and subnet 64 caught my eye, because they don't seem to be about building AI models at all. They seem to be about infrastructure.
Yes. This is what some people call the plumbing of the AI world. This is the stuff that runs in the background. So subnet 51 is a project called Celium, and it's a decentralized GPU rental marketplace.
Okay, so a marketplace for computer chips.
Exactly. Think about it. Everyone in AI needs chips. NVIDIA H100s, H200s, they are the oil of the 21st century.
And they are incredibly expensive and notoriously hard to get your hands on. There are waiting lists.
Right. Celium's goal is to connect people who have these powerful chips sitting idle. Maybe a university has some overnight capacity, or a crypto miner has repurposed their rig with people who need to rent that compute power. It tries to optimize the global supply of compute.
So it's trying to compete directly with Amazon Web Services or Google Cloud.
Directly. And then right alongside it, you have Shoots, which is subnet 64. They focus on serverless AI compute. The sources we have report that they are offering compute costs that are up to 85% lower than the big centralized providers.
85% lower. That is a massive number. How is that even possible?
It is massive. And it's possible because they're tapping into this global distributed supply of hardware that doesn't have the corporate overhead of a giant entity like Amazon. And because it's a hyper-competitive market, the miners on that subnet are constantly undercutting each other on price to get the job. It's ruthless efficiency.
Okay, so that's compute. That's the hardware layer. What about security? We talked earlier about the dangers of AI, things getting out of control.
There are subnets for that too. A really good example is Bitmind, which is subnet 34. Their entire focus is on deepfake detection.
Which is a gigantic issue in 2026. I feel like I can't trust any video I see on my timeline anymore. It's a huge problem.
It's one of the biggest. Bitmind uses the power of the decentralized network to identify AI-generated content in media files. And the reason it's so powerful is because it's decentralized. You have thousands of miners all competing to build the best possible detector. So if a new deepfake technology comes out tomorrow, the miners on that subnet have to adapt their models instantly to catch it, or they stop earning money.
That's a great point. The financial pressure forces them to innovate faster. If a traditional antivirus company like McAfee takes 6 months to release an update, they might lose some subscribers. If a miner on Bitmind fails to update for a week, they don't eat.
Exactly. It's survival of the fittest code in real time.
What about Targan?
Yeah.
I saw that name pop up in the security section of the docs.
Targan is subnet 4. They're a bit more technical. They do what's called deterministic verification. It's basically a security layer for the network itself. They provide a service to other subnets to ensure that the miners aren't faking their work, that the compute they claim to have done was actually performed. It's like an auditor for the network.
And then there's the science stuff. This one, I have to admit, this blew my mind. Subnet 25.
Protein folding.
Yeah, this feels like a huge step. Moving beyond just financial speculation or text generation into real, tangible scientific research.
This is where you really start to see the potential for public good. They are using the network's compute to simulate complex biological processes. The source mentioned they had already folded over 160,000 unique proteins. This is work that directly helps cure diseases. It accelerates drug discovery, and it's being done by a decentralized network of computers that are being incentivized by a crypto token. It's a wild combination.
It really creates this picture of what the community calls a macrocosmos.
That's the term they use, the macrocosmos pipeline. And you can start to see how data could flow through these different specialized subnets, like a factory assembly line.
How does that work?
Well, you can imagine, for example, subnet 13, which specializes in data scraping, collecting a massive data set from the web. Then that data gets passed to subnet 9, which specializes in pre-training large models. Then it moves to subnet 37 for fine-tuning that model on a very specific task. And finally, subnet 1, which is optimized for inference, handles the actual day-to-day interaction with the user.
It's a decentralized factory line for creating intelligence.
Exactly. And no single company owns the pipeline from start to finish. Each step is a competitive market.
Okay, this is a perfect transition. We have to talk about the money, the economics, because none of this works without the incentive layer. We keep mentioning TAO.
Native token, the fuel for the whole system.
Break down the tokenomics for us. What's to stop someone from looking at this and saying it's just another crypto pump and dump scheme?
Well, again, the structure borrows very heavily from Bitcoin to try and establish trust and predictability. First and foremost, there is a maximum supply of 21 million TAO. That number is hard-coded into the protocol. It will never, ever change.
Hard cap scarcity, just like Bitcoin.
Scarcity is the foundation, and it also has a halving schedule. In fact, we just passed a massive milestone for the network. The very first halving happened in December 2025.
Just a couple of months ago.
Right. It reduced the daily emission of new TAO tokens from 7,200 down to 3,600. Just like with Bitcoin, this programmed supply shock is designed to increase scarcity and, theoretically, value over time. And just as importantly, the sources emphasize it was a fair launch. There was no initial coin offering, no pre-mine for the founders, no big allocation to venture capital firms before the public got in.
Which is incredibly rare in the crypto space these days. Usually the founders and early investors keep 20 or 30% for themselves.
Very rare. But the biggest economic shift, and this is really important for understanding where we are today in 2026, was the introduction of dynamic TAO, or DTAO.
This was the big upgrade in early 2025.
February 2025. It was a massive, fundamental change to how the network operates. Before DTAO, there's something called the root network. It was basically a central committee made up of the top validators. And this committee decided how much funding, how many TAO emissions each subnet got.
That sounds really centralized. That sounds like a board of directors handing out budgets.
It was a centralization bottleneck. It was effectively a grant-giving organization. The committee would say, we think the image generation subnet deserves 10% of the rewards this month. It was slow, it was opaque, and it was very political.
And DTAO changed all of that.
It blew it up completely. DTAO introduced market-driven allocation. Now, any TAO holder can stake their tokens directly on the specific subnets they believe in. If you think the protein-folding subnet is the most valuable and has the most potential, you stake your TAO there. The more stake a subnet attracts from the community, the more of the daily TAO rewards it generates for its miners and validators.
So it turned Bittensor from a grant committee into a kind of stock market for intelligence.
A decentralized venture capital ecosystem is the best way to think about it. The market decides what intelligence is valuable. If a subnet is useless or isn't performing, people will pull their stake, its funding dries up, and it dies. If it's creating incredible value, it attracts capital and grows.
But markets can be messy. Markets can be irrational and driven by hype.
Oh, they can be extremely messy. Yes.
And the sources mentioned the LOL subnet incident. We have to talk about this. This is a perfect example.
Subnet 281, the infamous LOL subnet.
What happened there? It sounds ridiculous.
It was a classic case of people gaming the new system. The owners of that subnet basically realized they could create a subnet that didn't do anything particularly useful. Instead, they just encouraged pure speculation. They hyped up their subnet, created a narrative, got people to buy in and stake on it simply to capture a slice of the network's emissions. They weren't providing real value. They were just playing the financial mechanics of the new DTAO system.
So it was a metagame, a pump and dump scheme within the larger system.
In a way, yes. It was a valuable, if painful, lesson for the network. It showed that when you unleash dynamic markets, you also unleash raw speculation. DTAO brought massive benefits in terms of decentralizing capital allocation, but it also introduced brand new risks. It proved that the network will fund whatever the market wants, and sometimes what the market wants is just short-term speculative profit.
That leads perfectly into the next section, because I want to take a really critical look at this project now. It is not all sunshine and protein folding. We have this archive paper. The title is A Critical and Empirical empirical analysis of the Bittensor network, and it pulls absolutely no punches.
No, it doesn't. It's a very sobering read. It dives into the on-chain data to see if the reality of the network matches the marketing slogans.
And the very first thing it hits, and it hits it hard, is the concentration problem.
Right. We talk a good game about decentralization, but the data in that paper shows that the top 1% of wallets control roughly 90% of the total staked TAO. The Gini coefficient, which is a statistical measure of wealth inequality, is around 0.98 on a scale of 0 to 1.
That is astronomical. That's higher than the wealth inequality in most dictatorships. That's higher than North Korea.
It is an extreme concentration of wealth. And the analysis showed a very high correlation over 0.8 between the amount of stake a validator has and the rewards they earn. In other words, the rich get richer. And that leads to the critical question: if a few large validators control the majority of the scores, are we really that different from Google or OpenAI? If 3 guys in a room can collude and control the consensus, it's just a different kind of boardroom.
That feels like it destroys the whole value proposition, doesn't it? If I'm just replacing Sam Altman with, Crypto Whale 99 on Discord, I haven't really solved the core problem of centralization.
It's a very fair criticism. The counter-argument from the community would be that Crypto Whale 99 has a direct, transparent financial incentive to keep the network healthy and valuable, whereas Sam Altman has a more complex corporate fiduciary duty. But the concentration is real, and it leads directly to a genuine security risk, the 51% attack.
This was the most alarming part of the analysis for me. In a network like Bitcoin, getting 51% of the hash power to attack the network is fantastically expensive. You need warehouses full of specialized hardware and your own power plants. But in Bittensor, because of the subnet structure, the barrier to controlling a market can be much, much lower.
Specifically in the smaller, newer subnets. The paper did the math and found that in many of these subnets, a coalition of just 1% or 2% of the total network wallets could theoretically control the consensus for that specific market. In the really small nascent ones, it's less than 0.5%.
So a whale, someone with a lot of TAO, can just swim into a new promising subnet, buy up all the influence, and completely rig the game.
Theoretically, yes. They can dominate the consensus with their stake and effectively award all the prizes to their own minor operations. It makes it incredibly difficult for honest, smaller newcomers to compete if a whale decides to take over their subnet.
And we know the network isn't invincible. It's not just a theoretical risk. We have the hack from July 2024.
The $8 million exploit, a dark day for the network.
Walk us through that. What actually happened? It wasn't a flaw in the blockchain itself, was it?
No, and that's an important distinction. It was a supply chain attack. A malicious software package was uploaded to PyPI, the official Python package index. Bittensor users, miners, and validators downloaded this package thinking it was a legitimate update to their software, but it contained code that compromised their private keys, their wallets. It drained funds directly.
That's terrifying. But the response from the core team was also pretty controversial, wasn't it?
It was a real test of their principles. In response to the hack, the network went into safe mode. And what that means is that the Open Tensor Foundation, the core development entity, essentially hit a kill switch. They halted the chain.
Which proves?
It proves that, at least in 2024, it wasn't fully decentralized. If a central entity, no matter how benevolent, can turn it off, then it's not truly censorship resistant yet. It highlighted that a form of proof of authority was still heavily relied upon during emergencies, which runs counter to the whole decentralization ethos.
So we've got centralization of wealth, a vulnerability to whales and small subnets, and a centralized kill switch. That's a pretty rough scorecard for a project that sells itself on decentralization. But the protocol has evolved since then. The sources mention MEV Shield and YC3. Are these the fixes?
Yes. This is the network learning from its wounds. MEV Shield is a direct response to financial exploitation. It's about encrypting transactions in the mempool.
Okay, the mempool is the waiting room where transactions sit before they get processed by the blockchain.
Right. And previously, that waiting room was transparent. So sophisticated attackers could see a big transaction coming, say a validator, unstaking a large amount of TAO, and they could front-run it. They could jump in line ahead of it to exploit the price movement it would cause. MEV Shield encrypts all that data so attackers can't see what's coming until it's too late. It closes that specific attack vector.
And YC3. That stands for Yuma Consensus 3, the third iteration.
This is the evolution of that core scoring mechanism we talked about. It was designed specifically to fix that groupthink or copycat problem. It tries to incentivize validators to be more independent in their judgments. It actually rewards them for spotting new, high-quality miners early, before the rest of the crowd does.
So it actually pays to be a contrarian, as long as you're a correct contrarian.
It pays to be a good talent scout. That's the idea. If you just copy the votes of the big established validators, you get diminishing returns. But if you are the first to find the diamond in the rough, a brilliant new miner, you get a special differentiated bond reward. It's a direct attempt to break up that centralization of thought and reward independent analysis.
It really feels like a constant arms race, doesn't it? Between the people trying to exploit the system and the developers trying to patch it.
That is the nature of all complex decentralized systems. They are living, evolving organisms. They have to adapt to their environment, which includes attackers, or they die.
So let's zoom out. Looking at where we are now, in early 2026, who is Bittensor actually fighting? Who is the competition in this space?
Well, on one hand, you have the obvious ones, the centralized giants, OpenAI, Google, Anthropic. They are the Goliaths. Bittensor is trying to be the swarm of Davids.
What about in the decentralized world? The crypto AI space is getting very crowded.
It is. And the biggest competitor there is probably the ASI Alliance. That's the massive merger of three other big AI crypto projects.
Yeah.
Fetch.ai, SingularityNet, and Ocean Protocol.
Right, the super merger that happened last year.
The sources we looked at draw a really interesting contrast here. The ASI Alliance is very much focused on being consumer-facing. They are building agents, autonomous AI bots that go out and do things for you, booking your flights, negotiating prices for goods, acting as your personal digital assistant.
Bittensor is different.
Bittensor is positioned as the coordination layer. It's the infrastructure. It's the ground floor. Bittensor doesn't necessarily care what the AI does. It cares about creating the most efficient possible market to produce that AI, whatever it is. It's the concrete foundation that those agents from ASI might one day walk on.
So ASI is building the flashy robot, and Bittensor is building the power grid that makes the robot run.
That's a very fair way to put it. And that leads to the ultimate speculation, the ultimate goal for everyone in this space. AGI, Artificial General Intelligence.
The holy grail, the machine that can reason and learn like a human across any domain.
Everyone in AI is asking, how do we get to AGI? And the centralized view, the OpenAI view, is essentially make the model bigger, give it more data, throw more chips at it, build one giant all-knowing brain.
The God model.
The God model, right. But the Bittensor view is fundamentally different. It's a vision of collective intelligence. The theory is that AGI won't emerge from one single monolithic model. It will emerge from the interaction of thousands of hyper-specialized subnets. You'll have one subnet that is a grandmaster of logic. Another is a master of creative writing. Another knows all of biology. Another is the best coder in the world.
And they all talk to each other.
They transact with each other. The coding subnet might pay the logic subnet to check its work for errors. The biology subnet might pay the data scraping subnet for the latest research papers. AGI emerges from the complex economic network of these specialists, not from a single server farm.
That is a wildly different vision. It's less like building a single brain and more like building a digital version of human society.
Yeah.
We are all specialists, and we trade our skills with each other to build civilization.
Exactly. No single human is AGI. But human civilization, collectively, is pretty close. Bittensor is trying to build a digital civilization for intelligence.
And privacy has to play a huge role in that, right?
Right.
Especially now, in 2026, we are seeing this massive focus on confidential computing.
It's the next frontier, you're right. Specifically with the target subnet we mentioned earlier, as AI gets more integrated into our lives, we're sending it our private health data, our financial data, our personal secrets. We need to be able to trust that the miners who are processing that data can't actually read it. Confidential computing and eventually things like quantum resistance are absolutely essential for making this network secure enough for mainstream adoption.
So let's try to wrap this all up. We've covered a huge amount of ground: the Bitcoin-like philosophy, the subnets, the tokenomics, the ugly hacks, the centralization risks.
It is a vast, complex, and rapidly evolving experiment. It is definitely not a finished product.
It's messy.
It's very messy. It has very real centralization issues. It has people constantly trying to game the incentives.
Yeah.
But it remains the largest, and I would argue the most serious decentralized attempt to unseat big tech's growing monopoly on artificial intelligence.
So, for the listener, the person trying to make sense of this all, why should they care? What's the so what here?
Because right now, for most people, AI is something you use. You are a customer, you pay your subscription to OpenAI or Google, and you get what they decide to give you. You're on their platform, playing by their rules.
You're a passenger in their car.
You're a passenger. Bittensor proposes a future where AI is something you can actually participate in. You can run a miner from your home. You can stake on a subnet you believe in. You can vote on the direction of the technology. It proposes a future where you can own a piece of the global brain.
That is a profound shift in the power dynamic.
It is. It's a shift from being a user to being an owner.
I want to leave the listeners with one final thought.
Yeah.
Something to chew on after we sign off.
I've been thinking about this analogy all day. If data is the new oil and intelligence is the engine that runs on it, then the most important question isn't just who builds the best, fastest engine. It's whether we all get a set of keys or if we're just destined to be passengers in someone else's car. Bittensor is trying, against long odds, to hand out keys. It might be a bumpy ride, the engine might sputter sometimes, but at least you have a chance to be in the driver's seat.
And on that note, we're going to sign off. Thanks for listening to The Deep Dive. Keep learning.
See you next time.